The technical definition of working with an ellipse, and this is a lot easier for me to show if I use my computer. An ellipse, guys, really, please. An ellipse is basically a scrunched up circle. If you want to think of it here, I'm going to use the cursor to point out some stuff. On an ellipse, you have vertices on the outer edges. Vertices always look at foci, and then you have the center of them. These values of what are called A's and B's, the sum of A and B stays constant as you go around an ellipse. That's what makes an ellipse an ellipse. Now, the ellipse can be either stretched left and right, like this one is, or if you tilt your head sideways, it would be stretched vertically.
How many people?
You'd be surprised. But it's true, though. You can go either direction. It just depends on how things are scrunched. So what the ellipse does is that there's going to be this formula for these values of A and B, where this value of A, if A and B equaled the same value, you would no longer have an ellipse. You would actually have a circle. That's how we're going to be able to distinguish between ellipses, circles, and then tomorrow it's very easy to tell the difference between a hyperbola with their generic forms of equations. Now, what I usually like to do with an ellipse is just kind of show you guys the two generic formulas when we're centered at the origin to start with, and then explain what the parts mean as we go along. So you have two formulas. We're going to have one where it is stretched left and right, and we'll have one that it's stretched vertically. They're basically the same exact formula with one subtle difference, where the location of the A's and B's go. All right? So with these conic sections, we're going to have x squared over a squared plus y squared over b squared, equals 1. That's what the equation is going to look like if it is stretched left and right. Now, what's really nice is that if you take out your calculator, these formulas are there. These formulas are stored in your calculator, but they have it in terms of the shifted part already. They have the h and k thrown in. Today, our h's and k's are going to be at 0. Let me show you where you can find them on the calculator so you don't forget where they are. If I go to the calculator and turn on the calculator, there is a button. There's a button that says apps. It's right next to the button that says math. Math apps programs. So it's apps. When you select that, there's a ton of different apps that are stored in the calculator. We're looking for the one that deals with conics.
I only have one.
What's that?
I only have finance.
Oh, you don't have conics?
No.
Swing in. If you don't have the app, let me know later on, and I will send the app to your calculator using the cord. I just I'll go through this junk first. And we should have a couple minutes at the end of the hour. It only takes a minute or two. Okay. What's nice is that way the calculator has the formulas on there, and if you look at conics, we're talking about ellipses today. You'll see that there's 2 of them. Now, for us cool people, ours has got some color scheme to it. See how it has the a squared underneath the x value, and it's stretched left and right? And then if it's stretched vertically, notice what happens to the a squared value. It switches, which means we have to understand what the rule is for a squared. And this is going to be the same rule for today for ellipses, and then tomorrow with hyperbolas. A squared is always going to be the bigger of the two numbers. A squared will always be bigger than b squared. So when we wind up looking at these equations, it's not going to specifically say, oh, a squared is 7 and b squared is 6. You're going to have to interpret from the equation which one's bigger. So that way you know which way things are being stretched. And then just the process from going there. Okay? What's that?
So B is bigger, B
You'll see in a second. Okay. A squared, if basically it's going up like this. Which one's bigger, 9 or a 16? So 16 is playing the role of a squared, 9 is playing the role of b squared. That's
I thought that was a 10 to Q.
oh. There. That's what it'll be. Let me give you a couple examples, and you'll trust me, you're going to be fine. So what these values are going to do, and what these things all mean, we're going to have these a values, these b values, stretching you directions from vertices to focus to co-vertices to all these different things, and we just have to understand how we find them. So if I have a center at the origin, my vertice going left and right, my co-vertice would go up and down. So if I'm being stretched left and right, this value of A is always the distance from the center to vertex. A will always be the distance from the center to the vertex. So today it's really nice. Being centered at the origin, our A value will always be very easy to count because 0 plus A is going to be your vertex. B is always going to be the distance to what's called the, from the center to what's called the co-vertex. The way you're stretched is called the major axis. So if it's stretched left and right, your vertex goes left and right. Your co-vertex is when it's squished, and that's called the minor axis. So that will be vertical. Yeah, for an ellipse, whether they're stretched left and right or up and down, the ones that are further away will always be your vertex. Okay? So then we have this, this value of C. This value of C is always going to be the distance from the center to the foci. We don't have that yet, do we? We have to figure that out. So just like a parabola, remember the parabola always opened up to its focus, whether it was upright, left, down, to the left, right, wherever. It always opened up to the focus. Well, an ellipse basically is a dual enclosed parabola, so that means there's going to be two foci. So if they're going to be inside one another, will that value of C be greater or less than A? Less. The value of C is going to be, it's going to have, I shouldn't say less, it should have a smaller absolute value. It'd be closer to the center. Right? It'd be closer to the center. So how we find this value of C for an ellipse is this. The value of C squared is going to be the value of A squared minus B squared. It's almost. Hyperbola will be the factor. I'll explain why that is tomorrow. So basically what I want you guys to see here is when we start working with ellipses, the formulas are identical except for the fact of where the value of A's and B's can switch, because that's how you go left and right or vertical. So left and right, A squared is underneath here. It's always a plus sign between these two. So this is stretched left and right. The other formula would be this. And that means it's stretched vertical. C squared is always A squared minus B squared. And A is distance from center to vertex. As B is the distance from center to co-vertex. And C is the distance from center to foci. Foci is the plural of focus. Yes, sir?
So the only difference between the two of them are the x squared and that top one there and your switch. So
Yeah.
everything else is the same.
Yes, sir?
Thank you.
Yeah, and what's nice is that these A, B's, and C values What they mean again tomorrow with hyperbolas is the same. A is still going to be the distance from the center to the vertex. B is still going to be the center to the, what's called, it's not technically called the co-vertex, but I call it that. And then C is still going to be the distance to this, from center to focus. But how we find it is just going to be slightly different. One thing to remind yourselves is, ellipses are always plus between. The C value is always minus between. Hyperbolas tomorrow will be minus between, and the C value would be plus between. They're opposite one another. I'll show you. Okay. So real easy, just by looking at A, B's, and C's for something like this, I know that my center is going to be at 0, 0, and it's going to be like that for everything we do today. My co-vertex, or my vertices, is this distance from center to vertex. A, negative A. So it's A, 0, negative A, and 0. Co-vertex is vertical, so it's going to be B, negative B. It's 0 and B, and 0 and negative. And it's going to be really easy to write all of this stuff out when I give you guys a numerical answer or a numerical example. You all right? You're just looking at fancy pictures.
I'm trying to comprehend everything.
And then our focus. Remember, your focus and your vertex will always be on the same either horizontal line or the same vertical line, depending upon whether it's stretched left and right or stretched up and down. And it's going to be really easy to show how all of this works. Okay.
Is that negative A and 0?
Yeah. Yeah, because since we're centered at the origin, our A value is going to be the distance from center to vertex. So if I start at the origin and I go positive A, I'm going to the right. Negative A just goes to the left. That's all. And as soon as I throw something up with numbers, you'll be like, oh, that's what that meant. Yeah, wait a second, I'll show you that. You'll see real fast that this is extremely procedural. Okay, it's very, very procedural. It's not much craziness you have to freak out on your own here. Okay? Can I go to an example? All right, wait. All right, let's look. We have 9x squared plus 16y squared equals 144. We want to do everything. We want to graph, label, everything. Now, the generic form of the equation of the conics that we're dealing with, whether it's going to be an ellipse or an hyperbola, is that they're both going to wind up having to equal 1. So I need to figure out a way to make 144 equal 1, and I'll give you a hint. It's not by subtracting 143. Very good. You divide everything by 144. What's that? We're going to graph and label all the parts of this conic. I'd actually say, you'll know that's an ellipse today. What?
So for these, can you like take the square root of everything? Why?
Because there's a plus sign. You can only take square roots if it's jump squared equals something. So if I divide everything out by 144, you're going to be dealing with fractions. Oh, by the way, there's a button on your calculator that simplifies fractions. Alpha y equals. You don't get a,
I get a dust something.
you do, oh, do it as the fraction bar. You, that way it should work.
Oh, this is gonna go, right?
Very good. Yep, and that's exactly what I was hoping you would say. So notice, now you're in the standard form of an ellipse. You have x squared over 16 plus y squared over 9 equals 1. So just like Haley said, she recognized right away that 16 is bigger than 9. So that means the larger number is underneath the x squared. So that means it's going to be stretched left and right. So once you identify that, what I'd like you to do is put some quick sketch next to the problem to remind yourself that it has to go those directions. You'd be surprised at how many people forget to do that and they flip their things and they're all wrong. Okay? So now we start by labeling everything. What does a squared equal in this problem? A squared is 16. B squared is 9. C squared is going to equal a squared minus b squared, otherwise known as 7. You okay with that? Then I go to the next part. Well, if a squared is 16, a is going to equal what? Plus or minus 4. B is going to equal,
Plus or minus 3.
and then C is going to equal,
Plus or minus square root of 7.
there you go. What does A represent? Center to vertex. What does B represent? Center to covertex. What does C represent? Center to foci. Those are all your points you have to plot. Where do you start your problem at? At the center, at 0, 0. These problems today are all going to start at the origin. You don't have to worry about these things floating in space. When they float in space, it's just a matter of plotting to there and just moving it from that. It's still going to be, it's the same process. So if my center is at the origin, I know that my vertex has to go left and right. It has to go left and right how many? 4. There's my vertices. My co-vertices then have to go vertical. Up and down 3. There's my ellipse. Lastly, I have to identify where my foci go. Yeah, if you start thinking about it, square root of 7 is less than the square root of 9, but it's more than the square root of 4, so it's got to be somewhere between 2 and 3. So I'm at the center, I just go between 2 and 3 and call it a day, But the last thing I'm going to ask that you guys do with these is to label then where everything was. That meant my vertex, well, sorry, I start at the center. My center was at 0, 0. My vertex today was at 4, 0, negative 4, and 0. The co-vertex zero, 3. Bless you. And then bless you. Yes, I know most of you wanted to say, can I just say my center is at plus or my vertex is at plus or minus 4, comma 0. My covert, bless you, plus or minus is 0, plus or minus root 3. Please don't, because when we start putting things in that are shifted in space, they're not going to be that clean of values. I'd like you to list out both ordered pairs. Okay? Trust me, when we get to the shifting part, things float in space, you're going on list tag order pairs, it's going to be so much easier to identify where things are going. Okay? Believe it or not, there is a method to my madness. Yes, sir.
Why is the
What's that?
full
Square root of 7. Remember how we did that? We were doing an approximation yesterday. Square root of 7 is less than the square root of 9, but it's bigger than the square root of 4.
Okay, I just wasn't sure.
Yeah, that's all it was. We do that a lot in this section. We do a lot of those approximations for the roots. Okay? It's not terrible, is it?
It's a lot of work.
It is, but it's not hard. Try no. Yeah, I was going to change a little bit. So I start this one out, I have 25x squared, then I have a 4y squared, and it equals 100. What do you think your first step is going to be? Divide by 100, good. So if you divide everything by 100, notice we're not subtracting 99. We get x squared over 4 plus y squared over 25 is 1. And no, it doesn't always happen where they're reciprocal. We're not like, opposite of what you've already worked with. It doesn't always happen that way. It just seems like it. So, which one is your a squared? 25. Remember, a squared is always the bigger of the two. A squared is always the bigger of the two. You write that down again. A squared is always bigger than b squared. Okay? So, a squared is 25, so which direction is this stretched? Up and down, very good. So put a little note. Hey, knucklehead, it's stretching up and down. Okay? So go through the process again. A squared is 25. B squared is 4. C squared would be 25 minus 4. And you get all of that.
So you want us to keep like the square root of 21?
Yeah, because you can't simplify it. If it was the square root of 24, you could simplify it. All right? Because then you would, it's more important when we get to the ones that are shifted, because then you can write 3 plus 2 root 6, 3 minus 2 root 6, and it's a more of an exact answer. And then going from there. Just like when we had parabolas, whenever the parabola was closer to each other, skinnier, the focus was closer to the vertex. It does the same thing here. Notice the vertex and focus are only apart by a smidge. That's why it's a lot narrower. If the focus was further apart, it'd be a lot wider. Due to the fact of the limited time here, I'm not going to go and write down all the ordered pairs. I'm assuming after the first example, this is the same, except you're vertical. You guys can probably figure that out, right? So, yes, sir.
I know I'm
No, it's okay.
Guys, can you do those little like squiggly things?
Sure. By all means. That's you guys thought I was crazy by drawing those things crooked like that.
Oh, they really didn't
No,
help.
you're just crazy, so.
Yeah, Jordan,
Sometimes you have to write the equation given specific values. Now today it's not going to be so bad because everything's centered at the origin. But once you start remembering that the distance from the center to the vertex is A, the distance from the center to the focus is C, the distance from the center to the co-vertex is B. Once you start realizing what all that stuff means, writing out the equations is silly easy. Okay? So, again, yes ma'am?
How come for the last one, what made 5 the vertex?
The A squared was 25. So A squared was 25.
So A is always the vertex.
A is the square root of, A would be the square root of that.
Yeah.
And since we're at the origin, it's at 0. We start at this origin today. So I just go up 5 and down 5. That's all.
No, I mean, like, how come it's 5 instead of like 2? Is it just because we're going?
Because the A squared is the larger of the two values. And the A squared, if it's larger underneath the Y, it means it's stretched up and down. If it's larger underneath the X, it's stretched left and right. The way that it's stretched means it's stretching to the vertices. So the A represents the distance from center to vertex. Okay. Back to here. So if I know that I have a vertex at -4 and 0 and a focus at 2 and 0, what direction is this thing being stretched? Left and right. Very good. We know it's got to be stretched left and right because it's the ellipse or whatever is always going to open up towards its focus. The vertex is always going to look at a focus. Sir? Thank you. I did that second hour too. It's still looking that way, so we're okay. I actually put it at -2 now too. So the vertex is still going to look at a focus. It always does. Just like in parabolas. Okay? So that means that my value of A, since we're at the center to start today, how far is it from my center to my vertex? 4. How far is it from my center to my focus? 2. What's 2 squared? What's 4 squared? 16 minus what is 4? Yes, sir. Yeah.
Wouldn't it like not matter if you had it on the -2 because it's still like 2 away?
Yeah. It wouldn't have mattered. It wouldn't have mattered because we're still at the center. Well, so anyway, what was 16 minus what is 4? 12. So that means my B squared value, do I even need to know what B is? Well, it's the square root of 12, but if I'm just trying to write the equation of the ellipse, since we know this is going to be left and right.
-12? Or it doesn't matter, does it?
16 minus what is 4?
Oh, but like if you were gonna move the 12 over, then it'd be like 4 minus 16.
Which is?
Negative B squared. Oh,
In this case here, guys, it's just asking you to write the equation. You knew that your vertex, center to vertex is 4. That means A squared is 16. You found your B squared, it's 12. And you're done. It's the idea that knowing what A, B, and C represent. If you remember what the A, B, and C represent, and that when you're dealing with the ellipses, that C squared value is found by the subtraction of A squared and B squared. That's how you work with these. That's how you write out the equations. A lot of times when you're dealing with the stuff that are outside of the origin, you really have a lot less stuff to worry about. It's pretty quick. When we start floating in space, you'll have to start worrying about what values are repeated. our y value is repeated, which means it's stretched left and right. Our x value is repeated, so it means it's stretched vertically. Things like that. Let's do this one. If I have a vertex at 9, 0, and a co-vertex at 0, 2. If my vertex is at 9, 0, and my co-vertex is at 0, 2, which way is this stretched? Left and right, very good. It's stretched left and right because 9 is bigger than 2. And it's the x value, very good. So that means if I'm looking at it, if this is 9 and this is 2, it's going to do this. Wow, that's really bad, but you get the idea. What's that?
Because it's not drawn to scale.
Thank you. I should get that on like a t-shirt, not drawn to scale.
You already said that next slide.
Jordan, 7.
Wow, I really wasn't paying attention that day. So that means my A value is 9 and my B value is 2. Because they gave me the covertex. Do I need to worry about using the C value? Nope. Because the generic form of the equation doesn't even have anything to do with C. So your answer would have been x squared over 81 y squared over 4. And they're that quick. Well, it's the same idea as what goes on the test, but you're going to have to look at stuff like, oh, I didn't have that over.
Oh, I didn't finish it.
I'll cry.
Wait, you tried that last one,
Do you need the last one? I quit writing it down.
Well, it's going to be the same process of being able, not crying, but is that eventually you'll be given that. Graph and label everything.
I know.
Which means, like I said earlier, what do you think I'm going to have to do twice? No. Complete the square. What's half of negative 4?
This is going to confuse me if I do this.
When you square it, you're adding a 4 to both sides. What's half of 6?
3.
What's 3 squared?
9.
What's negative 4 plus 4 plus 9? Which conic is that? In order to set it equal to 1, what would you do?
Divide by 9.
You divide both sides by 9, you get this over 9. This over 9 equals 1. What is it?
It's,
Oh, you foiled.
I didn't foil anything.
what?
Oh, you get x squared
Are you
minus
asking what?
plus 4.
It's a circle. It's a circle centered at 2, negative 3 with a radius of 3. A and B are the same. If A and B are the same, it's a circle.
Wait, so A and B.
Yeah. I said this earlier. An ellipse is when A squared and B squared are different. They're the same as a circle.
Oh.
That's what we're heading towards.
I see now.
It's warm out. It was warm out second hour,
Do those, please.
third hour.
Meh. I don't know.
And then I have to come to like the rest of the day. Like I feel